Physics is often considered the cornerstone of the natural sciences. As the study of matter, energy, and the fundamental forces of nature, it not only unravels the mysteries of the universe, but also plays a central role in shaping the structure, quality, and direction of the entire education system. From primary schooling to advanced research, physics fosters critical thinking, cultivates curiosity, and empowers students to understand the principles that govern the world around them. This essay explores how physics contributes holistically to education, influencing other subjects, nurturing intellectual development, and laying the groundwork for technological and scientific progress. To foundational role of physics in science education. Physics serves as a base for understanding other sciences. Chemistry, biology, environmental science, and even geology rely heavily on physics principles. Concepts like energy transformation, thermodynamics, atomic structure, and electromagnetism are fundamental to all scientific inquiry. Without a basic understanding of physics, chemists can't understand reaction kinetics or molecular interactions. Biologists struggle to explain muscle mechanics or nerve conduction. Environmental scientists can't model climate systems or understand heat flow. In school curricula, physics is introduced early, often intertwined with general science, to develop students' logical reasoning and problem-solving skills. This early introduction is critical in setting the stage for more advanced studies in both science and engineering fields. Physics as a bridge between disciplines. Physics isn't confined to laboratories or equations. It forms bridges between diverse domains, mathematics and reality. Physics uses mathematical tools to explain real-world phenomena. Calculus, vectors, and algebra become meaningful in this context. Philosophy and science. The study of space, time, and causality touches philosophical questions. Economics and modeling. Statistical mechanics influence economic models and behavior analysis. The interdisciplinary nature of physics ensures students appreciate the interconnectedness of knowledge, leading to a more integrated and holistic education. Physics and technological literacy. A core aim of modern education is to prepare students for a technologically advanced world. Physics is at the heart of every technological device we use: mobile phones, medical imaging systems, satellite communication, internet networks, and renewable energy systems. By understanding physics, students gain insight into how these technologies work. This promotes informed citizenship in a tech-driven society, encourages innovation and invention, enhances employability in tech sectors. Schools that emphasize physics enable students to adapt to rapid technological changes with confidence and competence. 5. Physics in curriculum development. National education boards across the world emphasize physics because it builds cognitive structure and logical reasoning, aligns with global STEM education trends, offers project-based learning opportunities through experiments and simulations. Physics curricula often set a standard for academic rigor, including laboratory activities, modeling, and real-world applications. Physics education trains students in research methods and empirical thinking, skills valuable across all subjects. 6. Physics enhancing analytical and critical thinking. One of the most celebrated contributions of physics to education is its role in enhancing analytical and critical thinking skills. Physics problems often require breaking complex scenarios into simpler parts, applying abstract concepts to practical situations, evaluating different possible solutions based on evidence. These are transferable skills. Students trained in physics tend to perform better in areas involving logic, debate, and structured analysis. Physics teaches how to question assumptions, build models, test hypotheses, and make data-driven decisions, skills needed across academic disciplines and in life. 7. Physics in engineering and vocational education. Engineering education, mechanical, electrical, civil, or aerospace, is grounded in physics. Without physics, structural engineers can't design safe buildings. Electronics engineers can't build circuits. Automotive designers can't optimize vehicle aerodynamics. Vocational training in fields like solar technology, automotive repair, and electrical maintenance also rely on applied physics. Physics education helps students acquire hands-on skills, understand machinery, and engage meaningfully with technical systems. Physics in environmental and earth sciences. Environmental education heavily depends on physics. Understanding heat transfer explains global warming. Laws of motion and gravity help in modeling natural disasters like earthquakes or tsunamis. Radiation physics is key in nuclear safety and renewable energy systems. Earth science models like weather forecasting or ocean current analysis rely on physics-based simulation and satellite imaging. Physics gives tools to study and protect the environment, which makes it a vital element of sustainability education. 9. Physics in health and medical sciences. Modern medicine is deeply rooted in physics. Imaging techniques like X-rays, MRI, PET scans, and ultrasound are based on physical principles. Radiation therapy for cancer uses knowledge of nuclear physics. Biomechanics applies Newtonian mechanics to understand body movements. Moreover, physics plays a role in neuroscience, electrical potentials in neurons, cardiology, fluid dynamics of blood, and respiratory therapy, gas laws. Medical education increasingly incorporates physics to help future doctors and nurses understand the instruments and processes they rely on. Tenet role of physics in developing scientific temper education isn't only about information, it's about nurturing a mindset. Physics encourages evidence-based reasoning, the questioning of dogma, tolerance for uncertainty. This aligns with the goals of liberal education and democratic citizenship. A society educated in physics is more likely to make rational decisions on matters like vaccination, energy policy, or scientific research funding. 11. Contribution to educational technologies. Physics also enhances the very tools used in education. Projectors, microphones, and audio systems use optics and acoustics. Computers rely on semiconductor physics. Virtual labs and simulation software are based on physical modeling. Understanding the physics behind these tools empowers teachers to use them more effectively and students to appreciate their design and capabilities. 12. Physics and national educational policies. Many national policies, such as India's National Education Policy, NEP 2020, or the U.S. STEM initiatives, identify physics as a priority subject. Governments recognize that a nation strong in physics is strong in innovation. Physics education is crucial for defense, space, energy, and communication sectors. Investing in physics helps develop scientific and technical human resources. This leads to increased funding, competitive exams, and scholarships in physics-related areas, shaping the overall direction of education systems. 13. Impact on teaching methodologies. Physics education has pioneered several innovative teaching methodologies. Inquiry-based learning. Students explore principles through hands-on experiments. Flipped classrooms. Videos and simulations present theory. Classroom time is for problem solving. Blended learning combines traditional and digital tools for deeper understanding. Collaborative learning. Group projects and peer discussions mirror scientific collaboration. Such methods are now being adopted in teaching other subjects, showing physics' role in pedagogical advancement. 14. Career opportunities and interdisciplinary growth. Studying physics opens diverse career paths, academia and research, engineering and manufacturing, data science and software development, renewable energy and environmental consultancy, healthcare technology and instrumentation. Furthermore, physics supports interdisciplinary careers in artificial intelligence, quantum computing, nanotechnology, and materials science. These fields are reshaping global economies and education systems, making physics indispensable. 15. Conclusion. Physics is more than a school subject. It is a way of thinking, a foundation for progress, and a pillar of the modern education system. It nurtures curiosity, strengthens problem-solving, and drives technological innovation. From shaping the minds of young learners to fueling national development, the influence of physics on education is profound and far-reaching. By investing in physics education and making it accessible, engaging, and interdisciplinary, educators and policymakers can ensure a smarter, more competent, and more inventive society. In this way, physics truly empowers the whole education system, not just by teaching us how the universe works, but by showing us how to think, learn, and grow.